Okay, we'll get started. So it's week 9 already. I can't. It's so crazy. And I thought we'll take a look at SQL. See how we feel about that. So today I'll just start off with SQL, and then maybe on Friday I don't know, we can do more. We'll see how it goes. Okay, Data Camp has a course on SQL, and it's pretty good. I can link that. I guess I'll make it optional. Well, I don't know. We'll see. And then, we'll leave it as an optional thing. But I think probably one of the best resources for learning SQL is this W3 W3 resource. And it just has a whole bunch of exercises, like a lot. And all of these things, you'd kind of just click in the beginning. It says, SQL to retrieve data from tables, and it says, write a SQL statement to display all the information of salesman. And here it says your sample table is salesman, and it's got this. And how do we select all of the columns and rows from here? You're going to click the button or the answer. Click the answer, and it says the solution would write select star from salesman. Okay, and then and it doesn't have anything of this stuff, but basically this is all you're going to do. Alternate command would be select salesman ID, name, city, commission. Well, anyway, so we just do select star from salesman, and then it shows you a picture of what it's doing, and basically this is the salesman table. Star basically means select everything, and this is what it will return. All right, and that's that. The unfortunate thing is that SQL requires what's called an RDBMS, I think, a relational database management system. And so it requires you need to have some kind of server, a SQL server running, and the idea behind SQL is that the data is stored on this server. Usually we have huge things of data, and then you write a query, which is basically just a request in the SQL language. You send it to the server, and the server sends back the information that you've requested. Okay, so it's a little bit different from, say, R, where you load in data from a file, and that entire data set is stored in the memory of your computer. So if you have a huge thing and you don't have enough memory, then you run into problems. With SQL, SQL stands for Structured Query Language, and you have these very structured tables, and you write these things, and you might have huge tables, but it's all handled by the SQL server. So the unfortunate thing is that because of that setup, it's not exactly easy to get your, everything's relative, but you have to jump through a few hoops to get a SQL server like running on your own machine that you can then query yourself. So there are a few sources out there. One is called SQL Fiddle, and it's a web page, and basically you can load up the data. So this is just like a small database that we're setting up, and here we're setting up basically a few tables, and this is all written in the SQL language here as well. And I think if you click that link, it will load up the schema into SQL Fiddle. If you just type in sqlfiddle.com, it will start off with an empty schema panel, okay? But I think if you click the link, it will load it up with the schema that I've specified, okay? Well, actually, I'm just copying the tables in kind of the W3 schools, okay? The W3 resource. So here is the salesman table, which consists of columns: salesman ID, name, city, commission, and then it's got, you know, these 1, 2, 3, 4, 5, you know, 6 rows in here. Different salespeople, there's different cities, and they're different, I guess, commission percentages or whatever. I don't know what it is. Okay. And oops. So you click that and you build the schema up, and the schema is ready. And then over here, you can type in the commands that you would expect to use. So if we want to select everything from the salesman table, we would do select star from salesman. Are you guys able to read the text up on the screen? Is that, I don't know how much bigger I can make it. Okay. So I do select star from salesman, and we click run SQL, and it shows what that query returns, and it returns back basically everything in the salesman table. Okay. So we've got our rows, we got our names, our cities, our commissions, and things like that. Okay. The way we structure our queries in SQL is it's pretty simple, and I think it's pretty easy to understand. And there's a lot of similarities between SQL and kind of the way dplyr is set up. Okay, so you want to select certain columns. So for example, if we want to select just the column name, we would say select name from salesman. Okay, and it just selects the name column here. In the schema, I have 3 tables. One is create table, and then one is one is the salesman table, and then we got table orders and table customers. Okay, and in the schema, when you when you write SQL, you would write something like create a table, and you list off the columns. So our column names are salesman ID, which takes text, variable characters of length 11, so it takes text up to 11 characters long. Name, here it says variable characters 10, I probably should do something longer than that. City, 10 characters, and commission being 10 characters as well. Okay, and then we would insert our data into salesman, insert into basically these 4 columns, and the values that we enter go like this. Okay, and that's how we would write kind of the query language to insert data into a table. Now, you don't have to worry too much about this, because the database will already be set up, and basically most people's interaction with SQL is not setting up a database, not creating tables, but just querying and trying to get the information out of those tables. Okay, but if you wanted to delete a table, the command there is drop table. Okay, and so if I type in drop table salesman, and I run this, I guess it's smart enough to prevent me from doing that. Okay, but if you type in drop table and you type in the name, then it's going to delete the table, and that's a dangerous thing. Okay, you generally don't want to write the command drop. There's actually, just like everything else, there's a relevant xkcd drop tables, and basically you can. It used to be on web forms that ran on SQL. There was something known as a SQL injection attack. So most of the time in the web, you would write something like, there'd be a form that says, please enter your name, please enter your phone number, please enter something. But if your code wasn't kind of written to protect itself, people could, because generally the way the form would be set up is it would say, insert into the table, and then it would be like this, and then it would use the form data that says values this. And what people could do is they would write code that starts off with a quote, and so that closes off that command, and then you put in kind of the close parentheses and semicolon to indicate that part of the SQL command is done, and then you would say drop table star or something like this, and this would just delete all of the tables in the SQL database, right? And so anyway, you can see in here it says, did you really name your son Robert, and then close quote, parentheses, semicolon, and then drop table students or something. And we say, oh yes, little Bobby tables, we call them. This would be a way to kind of, it says, well, we've lost this year's student records. I hope you're happy. And it says, and I hope you've learned to sanitize your database inputs. These used to be, you can look up SQL injection attacks. Anyway, you would write kind of your commands to set this up, and then we would write our commands to interact. So most of the stuff I'm going to talk about is just going to be this interaction stuff. Okay, so basics, we'll start off with select. Now, the SQL commands are not case sensitive. So I could say select star from salesman, and it would work. But the convention is we write the SQL keywords in all caps, and then the column names and table names are all kept lowercase, so that when you're reading the code, you can distinguish between the SQL keywords and the things. Okay, so anyway, we can just do things like select name, name and city from salesman, the table salesman, and it would select exactly that, okay? If you wanted to, so if we look at city, so we can say select city from salesman, and we get the column, and we have New York, Paris, London, Paris, null, and Rome, okay? You can throw in the keyword distinct, okay? Select distinct city from salesman, and then that will get rid of the duplicate Paris in there, okay? So that's what we have. You can also perform things like aggregates. So you can say count, select count distinct city. So it feels funny saying select, but select basically, this is what we have to do in order to produce an output. Okay, if you don't have anything selected, it's not going to produce anything. So we'd say select count distinct city, and it would go through here and it would count all of the distinct entries that we have here. Okay, and it says we have 4. Okay, if it doesn't count the null as a distinct entry. Okay, so we have New York, Paris, London, and Rome. Those are our 4 values, and it doesn't select the null. Okay. You can also you can just do like count star, and this will count how many rows we have, and it will say you have 6 rows. Okay. You can also select under the select. You can do like math operations. So you can do like 6 divided by 2. Okay. And this will return 3. I guess 1 for every row. I don't know. It's not that. You probably wouldn't do that. Okay. You can apply kind of like filters and select only certain rows. So we can do something like select all the columns from salesman where city is equal to Paris, okay? Now, notice in SQL, we only use a single equal sign, not double equal. And this will select the rows in salesman where the city is equal to Paris. You can do, commission is technically a string, but I believe it will change it to numbers and allow us to do this, I think, yeah. So I can say select, everything from salesman where commission is greater than 0.12, and it filters down our table just so that it's only the rows where the commission rate is over 12%. So it doesn't pick Lawson hen, I guess. Okay. You can, there's also a way to check for null. So you can do where city is null, and it will select the row where city is null. And you can also do is not null, and it will pick everything else, okay? You can, let me see if I remember the commission. I think you say or not commission greater than 0.12, I think. Yeah, and so you'd throw the not in front of the condition here, and it would pull the ones where commission is less than or equal to 12%. Okay. Are you guys able to get the SQL fiddle thing up and just try some of these things out? This is by kind of fiddling around with SQL. It really is the best way to learn. Okay. The data camp exercises are helpful because they actually force you to write some code. SQL fiddle, I think, is also great. It's unstructured and you just kind of fiddle around with it, okay? You can have compound where statements. So you can do something like where city, and you can do in, and you can say is either Paris or London. Okay, so you can do that, and it will pull out the values where the city is Paris or London. Okay, you can also throw in an and. So a lot of times when we do when we write this, it'll be something like where city in Paris and London and Paris or London, and maybe and commission is greater than 0.12, or maybe I'll do less than 0.135. Okay, and that will you have kind of this compound thing. All right. You can also throw in ors. Okay, and so here, if we say cities in Paris and London, or the commission is less than 12% or something, this maybe, let's see. Okay, so we'll pull anything that has Paris and London, or if the commission's under 13% or something. All right, is that okay? If you're dealing with a numeric thing, you could do where commission is less than 13 and commission is, greater than or equal to 11%. Here we'll do less than or equal to 13 and greater than or equal to 11, and that will pull these four: Paris, London, Null, Rome, Nail, Pitt, Lawson, and Paul, and these all have values between 11, 12, and 13. You can also do where commission between can I write it this way? I don't know if I can write it backwards. I might complain. You can't write it backwards. You have to write between lower number and bigger number. Okay? So the previous statement where we had commission is greater than or equal to 11 and commission is less than or equal to 13 can be written this way, where commission is between 11 and 13. Okay, so that's one way to do that. Okay, is this all okay? So kind of the keywords we've covered so far are select, distinct, count. We have where, we have and, or, and between. Okay. And in, and you can do in providing some kind of, array of things that we have. Okay. You can also do where name, you can say is equal to James Hogue. Okay, and that would work. Okay. You can also, there is you can use a command called like, and like allows you to put in wildcard characters. Okay, so let's see what I have. I've got there's two names that start with P, so I can do P, and I don't think this will work. Okay, so if I say where name is like P, there's nothing that exists there. But, and this is kind of a funny thing, but the percent sign is the wildcard. So you do where the name is like P %, and basically it will pick anything that starts with a P and anything after that. Okay. Likewise, we could say where maybe salesman ID, and you can also put in wildcard characters like a blank. Okay, so this will be salesman ID starts with 5,000 and ends with a blank, and this will actually pull everybody because everyone's ID starts with 500 and is a blank. Okay, but you can do for example, if I changed this person to have a salesman ID starting at 4,000 and I ran this, then that person is not selected. Okay, but I'll change them back.
Does the blank mean just one character?
I believe the blank is just one character. Let me. So if I do 5 blank 6, yeah, that will not return anybody. But if I do 5% 6, this will return McLion. And then I can do like blank blank 6, and this will return the same. Okay.
So if you did 5 blank 6 is nothing.
So here I can do 5 blank 6 returns nothing. I can do blank A %, and this means where the second letter has to be the letter A, and we've got 4 people: James, Nail, Lawson, and Paul. Okay. let's see. Is there anything else? So these are all kind of ways to kind of filter your data. You can also aggregate your data here, okay? So, so we already saw an example of this. We can do count of commission from salesman, okay? And this will say we've got 6 values in the commission table. I could say return back the average of these 6 values, okay? And so we got 11, 12, 13, 13, 14, and 15, and apparently the average of those 6 values is 13, okay? If I did, I can combine this with a where statement. So I could say select average commission from salesman where city equals Paris. And it'll average the 2 people's commission rates for Paris. So we got 14 and 13%, and indeed it says the average of those values is 13.5%. Okay. So other words we have, other than average, we have sum. Okay. And then you have things like max. What's the max and min? Do I have standard deviation? What's SQL standard deviation? Standard dev. STDDEV. Okay. So we've got, that should work. STDDEV. And there you go. 0.005. I think it's 0.005, but I think because of floating point arithmetic, it has all these extra zeros in a 4-4. Okay. When you do something like this, select standard deviation commission, you can also combine them and you can say max of commission and the mean average. So actually, here I'm going to put these on separate lines, and it'll it does all of these things, okay? And we can also do count commission from salesman where city is equal to Paris, and it does this, okay? Now these become the column headings, and this is rather cumbersome, and we don't like that. So you can provide aliases. So you can do standard deviation as, and you can call it SD, and you can call this as, ooh, am I allowed to say as max? Okay, yeah, I am, okay. So you just say as mean and as n. Okay. And so now we have this, okay? So we have our things. So this is kind of like in dplyr you have summarize, right? You have the summarize command, and it's very similar. You provide the formula for how it's going to aggregate the things, and then you can provide a name to use it, okay? Instead of where city is equal to Paris, we can also provide, we can use the command group by, okay? And I can say group by city. And this will, you know what? This is not helpful. I need to have city in there. Okay, so we want to select the city, and we'll group by the city. Select Did I do something wrong? Select city, standard deviation. Yeah, okay. I'm not quite sure why I ran into problems. Okay, but you can we can group by the city value. Okay, and so we can say you know, London, New York, Paris, Rome. Okay, well these ones only have one entry, and so their you know, their max and their mean are the same, and the ends are all 1, and so they have no standard deviation. But this is similar to dplyr, right? Dplyr has group by functions, and you can do this. Okay. If I combine this with where, I can do where city is not null. Let's see, check the manual. Okay, sorry, I guess you have to, the order of the things that it, the order in which you write your commands matters. Okay, so here we're going to do our select. We tell it from which table, and we want to say we only want the cities that are not null. Okay, so we'll get rid of this value, the null city, and then we group by the city. Okay. You can also condition the row based on kind of these aggregated things. Okay, so we've aggregated I mean, there's not much to aggregate, but we can say, you know, I only want cities where there's more than one person. Okay, so I only want the ones where n is greater than 1. Okay, and that's different from your normal where. Okay, where is used for kind of which individual rows in the table we want, and then if we want to then kind of limit the results after having summarized that, the keyword there is having. Okay, and we would say having n greater than 1. And this returns only Paris, because that's the only one where it has the quality n is greater than 1. Is that good? Okay, so that's having. Oh dear. I don't know why. Okay. It's giving me some funny stuff. All right, having n greater than 1. Some of your queries will return like thousands of rows, and so if you want just like the head, you just want like the top 5 rows, you can do something called limit. Okay, and you'd say like limit 2, and it will return only the top 2 rows when you do that. Okay. So you don't have a head function, but you have limit. Okay. Is this all okay? I'm hoping it feels okay, because I feel like it's pretty similar to dplyr. The keywords are a little bit different, but kind of the reasoning behind it is should be familiar. Okay, and then the other part is doing some joins. Okay, and this is kind of where we do relational things. So let's say, let me see, how do I want to do this? Okay, so we've got a salesman table, which has a salesman ID, name, city, commission, and then we have an order table, which has order number, purchase amount, order date, customer ID, and salesman ID. Okay, so let's say I want to select the name. So from our salesman, we're going to select the name, and we'll do oh, I forget how to do this. I'll do select name and commission. Shoot. Okay, sorry. I have forgotten. Let's go to SQL joins. Okay, so under W3 resource, let's look at our answers. Okay, here it says write a SQL statement to prepare a list with salesman name, customer name, and their cities for the salesman and customer who belong to the same city. Okay, actually this is a better example. All right, number 2, write a SQL statement to make a list with the order number, the purchase amount, the customer name, and their cities for those orders, for those orders which order amount between 500 and 2,000. Okay, so we're going to look at kind of the amount here between 500 and 2,000. And in the orders table, we only have customer ID, and we need to get the customer name from the customer table here. Okay, and so I believe I have the orders and the customer table in there. Okay, and so so we'll look at the solution here. Okay. Okay, so we do. Okay, so we provide kind of aliases to our tables. So it says select A.order number, A.purchase amount, B.customer name, and B.city. Okay, because those are the things we want. We want the order number, the purchase amount, the customer name, and their city. Okay, and we're going to give orders the alias A and the customer table the alias B. Okay, we technically, I mean, the A and the B is technically optional, but it helps in keeping our SQL a little bit easier. Okay, so what we want is, so I'm going to do from orders A and customers B. Okay, so this is how we're going to name it, and then from there we want A dot order number, A dot purchase amount, B dot customer name, and B dot city. Okay, so we're selecting those 4 columns: order number, purchase amount, customer name, and city. And then from the orders table and the customers table, and we join them by saying where the customer ID of table A is equal to the customer ID of table B. A dot customer ID is equal to B dot customer ID. Okay, so if I run this, this will, oh, I called it customers, and the table is called customer. Okay, so this will pull everybody, and we want to filter where purchase amount is between 500 and what was it, 2,000? Yeah, between 500 and 2,000. Okay, so this is the where, and we're going to do and purchase amount and purchase amount between 500 and 2,000. Okay, and there you have it. We found Graham Zusi and Fabian Johns in California City. I don't think this is fake data.
Oh.
Whereas, well, there is a California City, but I don't think that's what they intended. Okay.
Where's California City?
I don't know. Where's California City? Somewhere. I think in California, but
Okay.
California City, California. It's not as well known as New York City, New York. But there we go. Okay. So we have joins there. Let's see. And it does have a nice picture representation. This SQL, I think if you're familiar with kind of query structure and filtering and stuff, you can pick up SQL quite easily here on your own. So we'll do. So here we're looking at we're selecting these columns, and we've already filtered between and said we only want between 500 and 2,000. Those are only these two things. And then as we look at the customer thing, we see that we want where customer ID over here is equal to the customer ID over here, and we combine those two together, and we get the results that we see. Okay. I think this is a great place to learn SQL. There's like a ton of exercises, probably a little bit overkill, but you can go through. So read through these things and say like, oh, does that sound like an interesting statement? Okay, so it says write a SQL statement to find the list of customers who appointed a salesman for their jobs who get a commission from the company that is more than 12%. Okay, so we want to find the customers who appointed a salesman. So we look at the customer, and then we're going to pick out the salesman ID where the commission is greater than 12%. So for something like this, once you have these things, you can try fiddling around and seeing if you can get the query right, and then at the end you can click the solution to see if you got it right. Okay, so let's see if we can try exercise 4. Write a SQL statement to find the list of customers who appointed a salesman for their jobs who get a commission from the company more than 12%. Okay, so we're going to go to the customer table and the salesman table. We're going to join it on salesman ID, and we want where the commission is greater than 12%. Okay, so we're going to pick from customer table, which we'll call A, and salesman, which we'll call B. We're going to join on salesman ID has to equal salesman ID. And I think we just want the customer name, where that, and we want B dot commission is greater than 0.12. Let's see if this is correct. Okay, so I have Nick, Graham, Fabian, Johns, Brad, Julian, and Green. I mean, maybe we want more stuff here. What's the salesman name? We'll just do name and B dot commission. I mean, this seems reasonable, but I mean, I know the original query didn't ask for all of those extra columns, but let's see if we got this right. Okay, customer name as customer name. Okay, I selected all these other things. city, name, salesman commission. From customer A, inner join salesman B on salesman ID equals B salesman ID where commission greater than 12. I think 1, 2, 3, 4, 5, 6. I think we have the same Josie Altador. This is clearly yeah, so I do have the thing. You know, just like everything else, you can get multiple answers. Oh, here we can do order by customer name. So let's do if we do customer name as, it makes sense to call this customer name, and then and since B name is the salesman name, it makes sense to give it an alias. Sales name. Salesperson. And sure, we'll select city as well. Order by salesperson. McLean, Paul, Anam, okay. I guess we're ordering by, they ordered by commissions. Well, it's all the same here. Okay. Is that all right? Going on here? So here I did a where. They did, in their code, they did an inner join, which is pretty much the same. Customer A is joined to salesman B on the salesman ID. Okay. So this is multiple ways to do all of these things. The joining is probably the most complex aspect of SQL, okay? But it allows you to perform quite powerful things because you can join multiple a bunch of things together, okay? So I recommend, if SQL is something that you're interested in, which is, it's often a highly sought out skill in the job market, I do believe this W3 resource is very good, okay? And you'll just kind of select here, and most of these things, a lot of these use just the tables that exist here. Here, let me just show you how to use SQL Fiddle, just because obviously if you just read the thing and then you click the solution, you'd be like, oh yeah, that's how I would have done it. But when you need to do it, it's good to try to get the answer yourself, right? So SQL Fiddle is very useful, but again, you need to have the tables set up there. So SQL Fiddle has this function called text to DDL. It's like text to database language something, okay? And so here, if you have something called like the movies database, right? It says, so this is like a huge table, and I think you can go to each of these things and just Control A to select all the text and Control C to copy it, and I think you can just paste it in here, and you call this movies, and you click append to DDL, and SQL Fiddle is like, it figured it out, okay? So it parsed it all up. You might have to check, but this looks pretty good. And so now we have a movies table, okay? So for these other exercises that exist and you want to create stuff using the tables, you can just kind of select Control A to select the entire table, and then you copy and paste it into this text to DDL feature, and then it will convert it into something that that then works. And so now you can select movie title from movies, and indeed it pulls off, it retrieves all of those things. Okay. All right. I think it's worth exploring a little bit more on Friday, SQL stuff. So we'll do that, and yeah, we'll see you guys then. Are your projects coming along okay? If you have any questions, like if you want to come see me during office hours because you need some guidance or things like that, I'm definitely available to help you guys with that. I would expect a few more questions by this point, but yeah, come on by. So a little bit. Yes.
For like committing our changes to GitHub, can we just first work on just like a normal script and then convert that into